This video will talk about the SIDLAB help menu, how to access it, and we'll also discuss a little bit about the tutorial models and how to use them. When you first bring up SIDLAB, you see up in the left corner the help menu. You can click on the help contents, and up will come a table of contents showing much about the theory and the models used in SIDLAB. We're going to talk about tutorials in a minute here, but before we do that, I want to show you also that you can go to the Search tab, and if you've got just something in mind, for example, Helmholtz resonators, in this case I've typed in H resonators, then you can list the topic, and then it will come up with every place in the help menu where H resonator is found. If you highlight one of those, you can display it. And off to the right you see an explanation of what a Helmholtz resonator is and the equations for the underlying theory that SIDLAB uses to model that type of resonator. There is also a tab for the favorites, so if you have favorite mufflers or favorite phrases that you want to save so you can access parts of the help menu later, you can store them here. But for now, we'll go back and we'll look at the tutorials. And the tutorials happen to be at the very bottom of the help menu. And so we will click on that, and then we will find what are the low frequency simulation models, or the plane wave models. First there is an expansion chamber. And this is a very simple expansion chamber muffler. Dimensions are in millimeters. And it shows you in the help menu how that is modeled in three different ways. One, using three different pipes, with the middle pipe being a larger diameter than the end pipes. Secondly, how to do it with the expansion chamber element. And a third way to do it with three pipes and an expansion and contraction element. I won't go into detail on this now because this is actually discussed in another tutorial that we've made. Second is a reactive muffler. This is a common muffler design also, where you have separate chambers connected by what are called transfer tubes. The interesting thing here is that there are uses of the quarter wave resonator element, and that's represented like this, as a pipe with another pipe on the side. But how to apply that is not so obvious. Number two is the quarter wave resonator. It applied for this space. Now, where is the side pipe? There is none, but the length of this side pipe is actually, in this case, the length, the distance from the inlet pipe to the end of the chamber. And when you do a SIDLAB model, you have to pick a direction. So actually, this is the direction back and forth. But because there is a wave that goes from the inlet and is reflected back this way, this volume acts like a quarter wave resonator. Also, number 4 is a quarter wave resonator, and its length is the distance from the transfer tube end to the baffle in the middle. So actually, it is modeling this, not the tube itself, the transfer tube itself, but the space around it. So this is something that will become more evident and obvious as you use SIDLAB, but at first it is not obvious how to apply the quarter wave resonators, but this is an example of one way that it's done. Next is a through-flow muffler. In this case, it's an expansion chamber with perforated pipe running straight through the middle, and it is actually modeled with a 4-port element rather than the standard 2-port. So what is a 4-port? Well, in this case, the 4-port is a perforated pipe, but also the volume. So you can connect the 4-port element at any of 4 ports. In this case, it's connected here and here, which is just through the pipe. But you could also connect it up here if you had reason to do that. In the upcoming tutorials will show that. So this is how you would model that. And the behavior is very much like a standard expansion chamber. You see these lobe-type behavior that a plain old expansion chamber would do, even if it did not have a perforated pipe in it. Next is the perforated pipe with absorption around it. So now this is demonstrating that if you add absorption around the perforated pipe, you get quite a different transmission loss curve. And that is modeled by actually just filling this space for this element with a higher flow resistivity. For example, in this case, it's glass wool with a flow resistivity of 4,000 rails per meter. And again, you see the transmission loss curve is quite different there. Next is a perforated plate muffler. This is just an expansion chamber with absorptive material stuck on one end and retained with a perforation. Now, there is an element in SIDLAB, which is this one, for plain old perforated plates. And you can adjust the parameters of that plate with the diameters of the holes, the number of the holes, or the porosity. And behind it is, of course, fiberglass, and it again has a resistivity of 4,000 rails per meter. In this case, even though it is a sort of a quarter wave resonator, it's modeled with just a pipe in which you change the flow resistivity to simulate the absorptive material. Next is a single plug muffler. Here the flow comes in one end through the perforations into the volume of the expansion chamber and then back into the perforations on the other side of the plug. This plug is just a solid piece of metal that separates both sides of this perforated pipe. Now there you see here in number 2 there is also just a pipe element. Now what is that? That is actually the area, the volume around the pipe, the plug. The length of this pipe is the thickness of the plug. So it's not a pipe per se, but it's a pipe representing the flow and the acoustic flow in the area around the plug. You can also model a double plug muffler like this, in which case you're now using 4 port elements, and more complex behavior, but yet it's doable in SIDLAB. Now, finally, here is an eccentric muffler, and it is a expansion chamber with 2 perforated pipes. Now, because it has 2 perforated pipes and a volume, now it is actually a 6-port element, because you can connect it at either end of the pipes, here, 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 or you can connect it in the volume itself, which is not done here because that is not where the exit pipe is. But nevertheless, it shows that there are 6-port elements that are necessary to use when you have 2 perforated pipes in an expansion chamber. Now, you can actually access these actual models in SIDLAB. They come with SIDLAB, so you can bring them in and practice changing parameters and see what that does for you. So, for example, we will open a project. All these are stored under example simulation, and you bring that up and bring in, for example, the expansion chamber. There it is. These are the different ways it was modeled, with 3 pipes, with an expansion chamber element, and so on. And we can look at it here. That's the 3 pipes. Say we want to go back and use the expansion chamber element. We can do that here. Say use that version. And then when we go to the display, now you see that it has the expansion chamber element between 2 pipes, which we talked about before. You can also, we'll bring in one more. We will bring in the through flow muffler and open it up. And now you see that there it is, the through flow muffler with the 4-port element and the 2 pipes on either side. This concludes the video on how to access the help menu and the tutorial models.